we are announcing the availability of streams plus ActiveActive. So what does that all mean? Streams, if you're unfamiliar with in Redis, have been available since Redis 5. They've been very, very popular since Redis 5 first came out. And essentially, they're log structure depend-only data model. Now, Redis has had a traditional pub/sub mechanism for many, many years. But you would only get those messages delivered if your client was connected when the message was pushed. What streams do is they add the restartability. So it means that from reading a stream's perspective, you can reconnect at any point and start your window or a point in that stream where you want to carry on reading from. So this is great in terms of the reliability, but also the additional things that streams provide is consumer groups. So I can now subset this stream by processing by different clients and making this a very scalable solution that is very reliable because of the restartability. So that's streams. What about ActiveActive? So ActiveActive, again, is a technology that's been available in Redis Enterprise for many years. But what it is intended to do is provide geo-replication between Redis clusters across availability zones, data centers, or even geographical regions. And the mechanism behind how this works is CRDTs, or conflict-free replicated data types. So this allows Redis to have automatic ways to resolve conflicts when two different clusters have performed writes against the same key. Because the inherent nature of Redis with its data structures and the operations it can perform against those data structures, it means that there is many different strategies can be employed by data type and by operation. And this allows for a very sophisticated approach to how those conflicts can be resolved. The great thing from a developer's perspective is that you get very low latency on those local writes. So you get all the characteristics of Redis you'd expect. Those low latency writes are then propagated to the other clusters, and they will eventually coalesce to a single value. So what does it look like if we combine these two technologies together? Well, this is a bit sort of complicated to follow, but let me try and walk you through it. So we have two clients, client 1, client 2. These can be in two separate clusters that are linked together with ActiveActive. So we see on step 1, an add to that stream takes place, and a read can occur, and you can see that value that's being added. If you now look at step 2 on client 2, reading that group means the entry is not visible because those changes have not been synchronized across the clusters. So we see at step 3, the synchronization is completed, and therefore the replication is completed. On client 1, we can acknowledge that we've processed that event, that entry, and if we now look at the stream again, it's empty. If we look at step 6, we can now see that on the second client, if I now do a read, because those changes have been synchronized, I can now see that value. And if we now go on to step 7, that after another synchronization has occurred, it means that that acknowledgement of that message by client 1 has now been synchronized. So when you go to read the group again, the entry is no longer visible. All right, so you've now created an application where you can process these streams in a globally distributed way, but ensuring that you're always getting a consistent view of those streams, irregardless of which cluster you are reading from. We think this is absolutely going to be awesome.